Propositional logic is very limited. As we saw in the beginning of this course, not every statement can be analyzed using logical connectives alone. For example, we might want to work with the statement, all primes greater than 2 are odd. So all primes greater than 2 are odd. To write this statement symbolically, we must use quantifiers. We can translate as follows here. We can say for all x, and our domain here is natural numbers, p of x, meaning x is prime, and x is greater than 2, implies that x is odd. In this case, we're using p of x to denote x is prime. So this means x is prime, and O of x is used to denote that x is odd. These are not propositions since their truth value depends on the input x. Better to think of P and O as denoting properties of their input. The technical term for these is predicates. And when we study them in logic, we need to use predicate logic. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below and make sure to click on that subscribe button. It is important to stress that predicate logic extends propositional logic, much in the way quantum mechanics extends classical mechanics. You will notice that our statement still used the propositional logical connectives. Everything that we learned about logical equivalence and deductions still applies. However, predicate logic allows us to analyze statements at a higher resolution, digging down into the individual propositions P, Q, and so on. A full treatment of predicate logic is beyond the scope of this course. One reason is that there's no systematic procedure for deciding whether two statements in predicate logic are logically equivalent, meaning that there is no analog to truth tables with this. So for that reason, we're not going to go that much further into this. If you want to study math more, I highly recommend taking a look at this. Thanks everyone, and I'll see you in the next video.